Hello, welcome to my channel Maths with Archana. Today let's learn the topic differential equation, and in this basically we'll learn the exact differential equation. So let's start. First of all, what do you mean by differential equation? So differential equation is nothing but differential equation. So differential equation is an equation involving the dependent variable and independent variable and their differential coefficients of various order, and it is called the differential equation. So what do you mean by dependent variable and independent variable? We know the first order derivative dy by dx. So here we are taking the derivative of y with respect to x. So here y is called the dependent variable and this x is independent variable. So dependent and independent variable means the variable whose value depends on the other variable. So here y is function of x means y's value is depend on this x value. So how we are using it in differential equation? So differential equation is equation which will have some y means dependent variable, some x means independent variable, and their differential coefficient. Differential coefficient means either you will have dy or dx or you will have dy by dx. For example, this is x dy by dx plus y equals to 0. This is differential equation. Or you can say sin x dy plus dx equals to 1. This is also differential equation as it is having some dependent variable, independent variable, and differential coefficient. Differential coefficient means dy dx like that. Okay. Now our exact topic for today is exact differential equation. So let's move to the exact differential equation. It's exact differential equation. So what does it mean? So consider equation of the form means obviously we are going to consider some differential equation. Suppose we are having differential equation like this: m x comma y dx plus n x comma y dy is equals to 0. Means here it is differential equation. Obviously, as we say, differential equation will have dependent variable, independent variable, and the differential coefficient means either means this dy and dx. So here suppose this is our differential equation. M is nothing but some function in terms of x and y. N is also the function in terms of x and y. So when we can say that this differential equation is exact. So if there exists a function u of xy such that this m dx means m xy dx plus n dy is equals to some du, then this differential equation is called exact differential equation. What does it mean? So m dx plus n dy equals to du. Du means derivative of u. U is some function of x and y. Means if you are able to write these differential equation as perfect derivative of some function, then we can say that our differential equation is exact differential equation. But by observation, you can't able to identify whether it is exact differential equation or not. So for that, there is a condition given that is called condition of exactness. Condition of exactness. Sorry. So what does it mean? Suppose you are having the differential equation m dx plus n dy is equals to 0. So m is nothing but coefficient of dx, n is nothing but coefficient of dy. So when can we say that this is exact? So the condition of exactness is nothing but this dou m upon dou y, if it is equal to dou n upon dou x, then we can say that the given differential equation is an exact differential equation. We know very well dou stands for the partial differentiation. As this m is and n is function of more than one variable, that is x and y. So the partial derivative of m with respect to y and the partial derivative of n with respect to x, if they are equal, we can say that the given differential equation is an exact differential equation. So how to remember? We are writing sequentially m, n, and x and y. So m's derivative with respect to y and n's derivative with respect to x. Obviously, it will be partial as m and n are the function of more than one variable. Now, we know that when there is differential equation, we have to find its solution as well. So for that purpose, let's see how to solve such differential equation when it is exact. So once we identified whether the equation is exact, then how to solve this? So to solve this, we are having the general solution formula that is called the general solution. So general solution is nothing but to find the solution of exact differential equation, you have to use this formula. It is nothing but integration of m dx, where you have to treat y as a constant. Because m is having both x and y, so either from that from that you have to keep y as a constant, plus integration terms of n not containing x dy is equal to c. See how this formula will work. So general solution is nothing but integration of m dx. We know that m is nothing but coefficient of this dx. And you have to take integration of terms of n which are without x. So we'll avoid the terms which are with x and take its integration with respect to y, and it is equals to c. For example, if you're having the differential equation like this, suppose you are having sin x plus xy dx plus y square plus 2xy dy is equals to 0. Suppose this is differential equation and suppose this is exact. I don't know whether it is exact or not for now. Just I have taken a random example. So you have to take the first taking. So suppose we'll assume it's exact. Then its integration will be, the general solution will be sin x plus xy. Here we'll keep y as a constant. Dx plus terms of n naught. This is m. M is nothing but the coefficient of dx and n is nothing but the coefficient of dy. So here terms of n not containing x. This term is without x. Let's take that. But this term is having some x. So we'll avoid this term. We'll write only dy is equals to some c. And in this way, you can find the general solution of some exact differential equation. Obviously, this equation is not exact. I have just taken it for an example to show how to implement the formula. The same formula can be implemented in other way. Just replace m by n and x by y. So n dy. Here you have to treat x as a constant plus terms of m not containing y dx is equals to c. So you can observe here that only m is replaced by n, x is replaced by y, and y is replaced by x. So the formula is same. If you're solving your differential equation, exact differential equation by either of these formula, you are going to get same answer. So that's your choice, which formula you are comfortable with. So you can use either this formula or this formula as well. Now let's see some examples of this exact differential equation. So suppose first example is x plus y minus 2 dx plus x minus y plus 4 dy is equals to 0. So obviously you can identify that this is a differential equation as it is having dependent, independent variable and some differential coefficient as well. But we don't know whether they are exact or not. So let's find out. So what will be m here? M is nothing but coefficient of this dx, that is x plus y minus 2. N is nothing but x minus y plus 4. So once you get these two values, how to find the whether it is exact or not. So for that, you need to find out first derivative as dou m upon dou y. So we know very well while taking partial derivative, when you are differentiating with respect to y, you have to keep x as a constant. So this is your m, x is constant. What will be derivative of x? 0. With respect to y, y's derivative will be 1. And as minus 2 is constant, it will be 0 again. So it is equal to 1. Let's find out dou n upon dou x. So here dou n upon dou x is equals to, with respect to x, y is constant. So x ka derivative with respect to x will be 1. Y's derivative as it is constant 0 and 4's derivative also 0. So this is equal to 1. So what can you observe here? You can observe here that dou m upon dou y is equals to dou n upon dou x. Therefore, given differential equation is an exact differential equation. Now we came to know that this given equation is exact differential equation. As it is exact, what you need to do? You have to find its general solution as the question is solved. So general solution is, I'm writing the formula for your information again, integration of m dx where y is constant plus terms of n not containing y, or not containing x, sorry, x dy is equals to c. So let's put the values in the formula. So general solution is integration of m dx. M is x plus y minus 2 dx. Here you have to treat y as a constant plus terms of n not containing x. So in n, this term is with x. So let's avoid this and take these two terms. So you will have minus y plus 4 dy is equals to c. Let's take the integration. So as y is constant and we are taking derivative, sorry, integration with respect to x. Integration of x is x square upon 2. As y is constant, its integration will be y into x. Integration of 2 will be 2x. Now we'll move here. So here with respect to y, y's integration will be y square upon 2 and plus 4 integration with respect to y will be 4y and it is equal to c, constant of integration. So this is nothing but we can say the solution of given differential equation. So let's see how we can simplify. We can actually multiply throughout by 2 to remove this denominator term, or you can keep like this also. So if you are simplifying further, it will be x square. I'm multiplying each term by 2, 2xy minus 4x minus y square plus 8y is equal to some 2c. 2c is nothing but some other constant c1. So in this way, we have to solve the differential equation solution, which is an exact differential equation. Now let's move to the next example. Second example is solve dy by dx is equal to tan y minus 2xy minus y upon x square minus x tan square y plus sec square of y. Now, firstly, you can observe in this example that we haven't provided it in terms of mdx plus ndy equals to 0. So firstly, it's really easy for us to convert it into the mdx plus ndy. So for that, cross multiply and take the other term, both the terms on same side. So m dx. So this will be our m. So I'm writing that further first of all. So it's tan y minus 2xy minus y dx. Now I'm taking this on other side. So it will be minus, or we'll write first of all cross multiplication, then we'll solve that. So it will be x square minus x tan square y plus sec square y dy. Now take this term on one side. So it will become tan y minus 2xy minus y dx minus x square minus x tan square y plus sec square y dy equal to 0. Now this is m dx minus n dy. So m will be here tan y minus 2xy minus y. And n will be x square minus x tan square y plus sec square of y. So you can observe here that we have got the m and n. So what we are left here with? Here we are left with the negative sign in between. So let's add the negative sign to each term. So negative, positive, and this will become again negative. This will be n. Now first of all find dou m upon dou y. So dou m upon dou y with respect to y, x will be constant. So dou m upon dou y will be sec square of y, tan y's derivative sec square of y. With respect to y, x is constant. So it will be 2x, and y's derivative with respect to y will be 1. We know very well sec square y minus 1 is nothing but tan square of y and minus 2x. Let's find dou n upon dou x now. So dou n upon dou x will be with respect to x minus 2x. Now with respect to x, y is constant. So x ka derivative is 1 and tan square y as it is. And sec square y is constant with respect to x. So its derivative will be 0. Now you can observe that dou m upon dou y is equals to dou n upon dou x. Therefore, given differential equation is an exact differential equation. As it is exact, let's find its general solution. So, general solution is, we know the formula integration of m dx, where y is constant, plus terms of n not containing x dy equal to c. So let's find m. M is nothing but tan y minus 2xy minus y. And with respect to x, it is so dx plus terms of n not containing x. So this first term contain x, this term contain x, neglect them. Only take this term without x, that is sec square of y, and which is equal to c. Therefore, solution will be, here you have to treat y as a constant. So as you are taking y as a constant, tan y is constant derivative is constant into x. So x into tan y it is. So this is confusing one. Now 2y is constant, derivative integration of x is x square upon 2. Here y is constant, its integration will be y into x. Now in the second term, sec square y. So sec square y's integration will be tan of y, which is equal to c. So in the next step, you can remove this 2 by multiplying each term by 2. Or here 2 got cancelled. So x is equals to tan y minus yx square minus yx minus tan y is equal to c. So this is solution of given differential equation. Now I am giving few examples for practice. You can note down this example, try them by yourself, check whether you are getting them exact or not. Then if they are exact, find its solution. So next example is solve y square e raised to x y square plus 4x cube dx plus 2xy e raised to x y square minus 3y square dy is equals to 0. Note down one more example. Solve 1 plus xy square dx plus 1 plus x square y dy is equals to 0. Try these examples. Note down first of all. Try this example to solve. Obviously, you're going to get them exact. And here they have already given in terms of m dx plus n dy. So this is m dx and dy equals to 0. Here this is m, this is n. Find out dou m upon dou y and dou m upon dou y and show that that is equal to dou n upon dou x. Then find its solution using general solution formula. So this is all about exact differential equation. So let's end the lecture here. Thank you all of you for your patience.